Hello everyone. Today we are going to record another session on the aelf blockchains tutorial series. This particular tutorial will focus on developing a decentralized application on expense tracker. This particular decentralized application will enable the user to manage and monitor their personal finances, and it will also provide a user-friendly interface to record, capture, and categorize and track the spending habits of a particular user. It will also securely store and verify the data on the aelf blockchain. We will complete this tutorial in 4 steps. In the first step, we will set up the development environment. In the next step, we will develop our smart contract for the expense tracker. And in the next step, we will deploy that smart contract on the aelf blockchain. And in the last step, we will create a front-end application to interact with the smart contract, which we deploy on the aelf blockchain. Let's start with our first step to set up our development environment. So to start with the setup, you should have basic knowledge of terminal commands. If you haven't installed an IDE, you can install VS Code by clicking on this link. Then you need to install .NET 6 version. If you haven't installed it yet, then you can click on this link to install it on your system. I will skip this step as I have already installed .NET on my system. Then we will install aelf contract templates using the following command. We will copy this command and we will paste this inside the terminal, and this will install aelf contract templates. So aelf contract templates contains the various predefined templates for the ease of developing the smart contract on aelf blockchain. We will then deploy the aelf deploy tool using the .NET tool install command. So this particular deploy tool is a utility tool to deploy smart contracts on the aelf blockchain. When you install the aelf deploy tool, then please remember to export the path after you done the installation. There is a export path command. You just copy that command and paste it inside your terminal so that you export the path. In the next step, we will install the Node.js and we will install Yarn. So to install Node.js, you can click on this link and download for your operating system. Same for Yarn, you can click on this link and download for your operating system. I already have installed Node.js and Yarn, so I will skip this step. In the next step, we will install the aelf command. So we'll copy this command and we will paste this inside terminal, which will install aelf command on our system. It requires sudo privileges to write some data, and please provide sudo privileges by entering the password after entering the command. It will install aelf command on your system. Aelf command is a CLI tool to interact with the aelf blockchain, which enables the task for creating the wallets and managing the transactions. It also requires permissions while installing the aelf command globally so that we can use it later on. This completes our first step of setting up the development environment. In the next step, we will develop our smart contract. For this, we need to start a smart contract project. So what we'll do, we will create a new directory to start our project, that is using the command mkdir expense tracker dApp. So we will do this inside folder aelf tutorials. In this folder, we will create a new directory using mkdir command. We will change to that directory, and then we will create a new aelf template, that is expense tracker template using .NET new aelf command. We will paste this command inside terminal, which will create a new template for the aelf contract project. You can verify this by entering the ls command. If source and test folders are there inside expense tracker, then it means you have created a template for expense tracker. In the next step, we will add our smart contract code. So this smart contract will focus on the expense tracker project, where users will be able to handle the basic functionality of adding an expense, updating a selected expense, or deleting a selected expense, and list all the expenses and retrieve the information of a specific expense from the contract state. Now, dApp includes the below functionalities, which are adding the expense, which I explained that it will help you add a new expense to the contract state. Then it will help you to update that particular expense on the contract. You can also delete the expense, and you can list all the expenses by the user, and you can also get the details of a particular expense. to develop, let's open the project that we just created, expense tracker in the aelf tutorials. So we'll go to that folder, we will open that. Let's open our expense tracker project in the VS Code. So we'll open this and you will see that there is a source folder and there is a test folder. Inside source folder, you will see a protobuf folder, and then there are three files. One is expense trackers CS file, one is CS project file, and one is the state file. Inside the protobuf folder, there is a contract folder. Inside that, you will see a file called hello world contract.proto. Let's proceed with renaming that particular file. So we will rename the proto file from hello world contract.proto to the expense tracker.proto. And inside terminal, we can change to source directory so that it helps us while building the contract once we finish developing the contract. So let's open the VS Code, and inside let's rename this file from hello world contract.proto to expense tracker proto. Let's open this file. Now, proto file helps us define the structure and the serialization of data, which ensures the consistent communication and the data exchange between the contract and the external systems. Now, let's implement this expense tracker proto file. We will copy the content of the next code sample to add in the proto file for our expense tracker. We will select the existing content, paste this here. The proto file defines the RPC methods like add expense, update expense, delete expense, list expenses, and get expense. It has other RPC methods like initialize and get initial status as well. Then it has messages which are similar to events. So some messages like expense input, expense update input, and expense list are also mentioned. We'll save this file and we'll move to our next step. This saves our proto file. Here, RPC methods define the callable functions within the contract, which allows the external system to interact with the contract logic. And the messages represent the structured data exchange between the contract and the external systems. Now let's define the contract state. Now we will go inside our source folder where there is a expense tracker state.cs file. We will copy the next code sample and we will paste it inside the state file, that is expense tracker state.cs. We'll select the whole content and we'll paste it here and we'll save this file. It defines certain states in our state file. The state file holds the variables that stores the contract data and makes sure that data is saved and accessible whenever the contract needs it. In the next step, we are going to implement the expense tracker smart contract. This particular smart contract will include the logic of all RPC methods which we have defined in the proto file. So in the next file, there is an expense tracker class which includes functions like initialize, where we initialize the state of the smart contract. In the next function, there is an add expense function which helps us adding a particular expense with the details about the expense from a certain owner. Then we have a function to update the expense which allows a user to update the expense by updating various fields which are part of the expense. Then there is a delete expense function which allows users to remove the expense from the list. And then there is a list expenses function which allows users to list all the expenses which a particular user has made. Then there is a get expense function to get the details of a particular selected expense. And then there is a get initial status function to get the initial status of the smart contract. Now let's copy this content of the smart contract and then let's paste it inside expense tracker.cs file. Let's select the whole content, delete it and paste the copied content for the implementation of the expense tracker smart contract. Now, as we have developed our smart contract, now let's try building the smart contract by going inside the source directory. As we have seen earlier as well, we mentioned that we will go to our source directory to build the project. So we will change directory to source. We'll change our directory to source inside terminal. Then we will run .NET build command to build our smart contract. So as we have completed the implementation of our smart contract, we have built our smart contract successfully as well. This particular step will create a bin folder where we will get a expense tracker.dll.pest file, which will be used in the next step when we deploy and interact with our smart contract. In the next step, we are going to deploy the smart contract on the aelf blockchain. To deploy a smart contract, we need a wallet, and in that wallet, we need some funds to deploy the smart contract. So first, we will create a new wallet to deploy the smart contract. So we will copy the next command, that is aelf command create, and we will paste this command inside terminal to create a new wallet. This will provide us with four fields. One is mnemonic, then private key, public key, and address. Address is a simplified form of the public key, and mnemonic is a simplified form of the private key, where public key and private key are the cryptographic primitives of a particular wallet in any blockchain. We'll press Y to save this information in a file and encrypt that with a password, and then we'll enter the password and confirm the password again, which will save this information in a file. Now, as we have created the wallet and saved the information in a file, we need to export some information inside our terminal so that we can use certain environment variables. So let's first export the wallet password so that we can use the information inside the file. So we'll export the wallet password. I use wallet password as Mohit at 123. Then we will export the wallet address in the next step, and the wallet address is the address which was generated using aelf command create. You can copy it from the last step where the last field is the address field. You can copy that and paste it here in this command, export the wallet address environment variable. In the next step, we are going to get some tokens to deploy our smart contract from a faucet. Faucet is running on aelf blockchain for the testnet to get some tokens to interact and deploy the smart contract on the aelf testnet. So let's copy the next command, which will get us some tokens, aelf tokens to deploy and interact with the smart contract. Let's copy this command and paste this command inside the terminal, and it will return us a variable called is success. If that is true, it means the last command ran successfully. We can verify this by getting the balance. We will find out the balance by copying the next command, and we will paste this command inside our terminal. Let me explain this command. This aelf command calls the multi-token contract, which is the address of the multi-token contract, which is starting from ASH, and then it uses the wallet address and wallet password information, where it can provide the wallet address to check the balance, and get balance is the function which is calling on test network, which is the URL of the test network here mentioned in the command. We'll enter this command and it will fetch the balance. It will ask for the token symbol to find the balance. So aelf is the token symbol and the owner is this address. So we'll copy this and we'll paste it here to find the balance. As you can see, the balance is 100 into 10 to power 8. 8 is the precision level on aelf blockchain token. So we got 100 aelf tokens using faucet. Now, as we have gotten the tokens to deploy our smart contract, we will move on to deploy our smart contract step. Before moving to the deployment step, let's export the contract path, the file which we created using the build phase of the smart contract, that is .dll.pest file. We will export the path of that file. We'll copy the next command and we will paste this command inside our terminal, and we will export the contract path. Then in the next step, we will deploy our smart contract using the aelf deploy command. We'll copy this command and we'll paste it inside the terminal and we will press enter. If you get this error that command not found aelf deploy, you can uninstall the aelf deploy tool and then you can install it again so that it works. So we'll uninstall it first and then we will install it again in our terminal. You might encounter this error sometimes. So this command will install the aelf deploy tool. Please do not forget to export the path inside the terminal. It will export the path of their tool, and then let's run the aelf deploy command again. This will start the deployment process of our smart contract. It will use the .dll.pest file which we created using the build step, and it will deploy our expense tracker smart contract on the aelf blockchain, where it will take the bytecode of this smart contract on a particular storage on the ELF blockchain, where it will provide an identity to this storage. This identity is called as the smart contract address, which we will use in the later stages to interact with the smart contracts. This address will be utilized to interact with all the functions which we have written inside this smart contract. Let's wait for this smart contract to deploy, and then we will start interacting with our smart contract in the next step on the front end. As you can see, we have successfully deployed the smart contract, and here you see an address field which is the identity of our smart contract, or you can say the address of our smart contract, which we will use in the later stages to interact with this smart contract. We can copy this in this step, and later on we will use this as well. As now we have successfully deployed our smart contract, you can export the contract address as well, which we can use in the later stages. So copy this export contract address command, paste it here, and take the address from the last step and paste it inside the same command, and then export the contract address as an environment variable. Now we have successfully deployed our smart contract, that is expense tracker smart contract. Now we will move to our next step, that is to interact with our deployed smart contract with a dApp. Now let's first clone another repo, that is aelf samples. As I have already cloned this repo, you can use this command to clone the repo. I will open this folder inside VS Code so that we can write the logic of this front end application. So there is a sample, there is a template already written to help you get started with the front end application, and then over that you can write the logic which I'm going to explain in this video later. Let's open aelf sample in our VS Code. Now we will open the add samples. Here we will see an expense tracker folder which we are going to use in this particular tutorial. Now, as we have cloned the project, let's change directory to our 2dApp directory, which is the front end template for this expense tracker dApp. Let's copy the next command, go inside terminal, and then change the directory to 2dApp inside aelf samples and then inside expense tracker dApp. Let's check whether we have made a mistake. So we need to first change to expense tracker, then we need to change to 2dApp. Now as we have changed our directory, now let's move to our next step. As you can see, the structure of this 2dApp will look like this. There are 4 folders: app, assets, public and source, and then there are certain files for a React application. Then we need to install the necessary libraries and packages. So we'll copy the next command, that is npm install, and we will install the required libraries and packages. Till these packages install, let me explain the next steps which we are going to take in this tutorial. First, we will configure the port key provider, that is a wallet on the ELF blockchain. Then we will write a function to connect the wallet. So there is a decentralized application which we need to connect to the blockchain, and the wallets are the software piece which helps connect a decentralized application with the blockchain. First we need to check the provider. The provider will be within the browser, so we'll check whether a portkey provider is present or not. Then we will ask the user to connect their wallet. If it is present, then we will write the logic in the front end to create the expense form, and then create an interface to add an expense, update an expense, and delete an expense. And then we will fetch all the expenses, and we will then run the application. Now, in the first step, let's configure the portkey provider. So first we need to go to the folder, that is source hooks, and we need to find a file that is use expense tracker smart contract.ts. There is a step A, where is a function to fetch a smart contract based on the deployed wallet address. First, it will check the provider, and then based on the deployed contract address, which we did in our last step, we'll have to use that address to check whether that smart contract is present on the blockchain or not. If it is present, then it will fetch the information of that smart contract. So let's copy this code sample and go to step A inside source, and then hooks, and then there is a file called use expense tracker smart contract.ts. So let's change this step A. There is an incomplete function implementation. Select that. Please do not duplicate that, and then paste the implementation of the function that is to fetch the contract. Now we can see this function. First check the provider whether it is present or not. Get chain is for the testnet of the ELF blockchain. TDVW is the testnet ID of ELF blockchain. Then we use the address. So the address which we used inside the expense tracker dApp which we created. So here is the address which we created during our deployment step. We'll copy that address, and let me just enlarge this for the better visualization. And we will copy this smart contract address. We will go back again, and then we will paste this address here. It is the smart contract address which will help us interact with the expense tracker smart contract. And then I will fetch the contract using the address from the blockchain, and then we will set the smart contract state, and we'll check for errors if there are any. Let's save this file. If you see the error in the npm install step, so you can use sudo, which might require sudo privileges to create some folders. So you can provide sudo privileges, and then can enter your password to install the necessary packages and libraries. Till this happen, let's move to our next step, that is to initialize and fetch the smart contract. I have already explained the fetch contract function which we did in the first step. Now let's initialize and fetch the smart contract. So now we need to use a hook to fetch the smart contract. So we have written the function to fetch the smart contract, but we need to use the hook in the React application. So now we will go to step B inside the same file, where we will have to find the use effect hook. Let's copy the next code sample and go to step B, where we need to select the current hook, and then we will paste this here. So once we paste this, it will finish our next step. Let's save the file. Now we have developed the hook. This hook initializes and fetches the smart contract. It simply calls the last function which we implemented, fetch contract. Now we are going to follow the steps to create forms and then provide the front end functionality to add, update, delete, and get the expenses data. So now before that, first let configure the connect wallet function. When we get the provider, when we connect with our smart contract, after that we connect our wallet first. So now we need to go to our source component layout header folder, and there is an index file where we need to find the step C to connect the wallet. Let's copy the next code sample, which is to connect the wallet. Let's go to source component. Then let me check again. This is source component layout and header. Inside header, there is an index file, and there is a step C inside this file. There is an incomplete function implementation. You need to select this and paste it here. And this is the implementation of the connect wallet functionality. So it will connect with your wallet provider, and then will connect the wallet, and then will show the information of the accounts inside the wallet, and will set the wallet address. We use some prefix and suffix, that is ELF and AELF for our addresses, and then it will set the state is connected to true, and then you will get a notification that your wallet is successfully connected. Then let's save this file, which will connect our wallet. Then in the next step, we will create the expense form. Now to add the expenses, we need to create a form. So we need to find step D inside pages folder. There is a home folder and there is an index file inside. Let's copy the step D. Let's go to our VS Code and paste this code sample. So inside there is pages, then there is home page and index file, and we need to find step D for that. Let's find step D here, and then we will complete the unfinished form. So let's delete the unfinished form and paste the new implementation, the complete implementation of the form, and let's save this file. Now let's move to our next step. This form simply initialize a new form variable. Now we will check if the contract is initialized or not. So to interact with the ELF smart contract, we need to initialize the smart contract first. So there is an initialize function which we wrote in our smart contract. So we need to check whether the contract is already initialized or not from our front end. So we'll copy the next code sample and we'll go inside source pages in the same file, home index.tsx file, and we'll check the step 1 there. Let's go there and check the step 1. This is the step 1 to check if the contract is initialized or not. Paste this logic here and we will save this file. Now, this particular initialize step is checking whether the contract has been initialized or not. Now, if it is not initialized, then we will initialize this contract. So we'll write the logic to initialize the contract. So we will copy the next code sample. Here you can see it is interacting with the smart contract where it is calling the initialize function RPC method which we wrote, and then providing us a notification that the contract is successfully initialized if it is successful, and returning an error if there is an error while initializing the smart contract. So let's copy the code sample and then go to step 2 to initialize the smart contract. Let's select this incomplete implementation and paste the complete implementation of the initialize contract function. Now we will add a new expense logic. So now we'll have to go to the step 3 in the same file. There is a function to add a new expense. So again, it will call another smart contract function, that is add expense function. First, it will create an object to send the data, which takes the description, amount, category, and what kind of currency you are using. And then it will call the smart contract function, that is add expense function, and then will show us the notification whether a particular new expense has been added or not. And if there is an error, then it will notify us the error. Let's copy this code sample, go to our step 3, that is to add a new expense, and finish this incomplete implementation of the function. Now, the next step, we will update the expense. We will update the expense using the next step function. So there is a function to update the expense, and there we are again calling the smart contract function. The fields which we want to update we can provide here, and along with that we need to provide the expense ID. The expense should already be added to get updated, and then we call the smart contract function, that is the update expense function, and then we will show the notification to the user whether the expense has been successfully updated or not. If not, we will show the error to the user. Copy the next code sample, and then we will go to step 4 to the same file and we will complete the implementation of update expense function. We'll save this file again. Now let's move to our next step, that is to delete the expense. So this particular function allows users to delete the expense which is selected by the user. Here it will call the delete expense function based on a particular selected expense. So there is an expense ID associated with an expense. So we'll delete an expense based on the expense ID. If it is deleted successfully, then we will notify the user that expense has been deleted successfully. If not, then we will notify the user with the corresponding error. So we'll copy the next code sample to paste the delete expense function inside the same file to complete the implementation of delete expense function. Now, in the next step, we will handle the form. Now we need to handle the submit form. So on submit should do something for us. So when we click on the on button, so it should initialize the contract, or if like some other action is being taken, the button should do that for us. So now we will copy the logic of on submit form and we will handle this logic in step 6, and then we will go to step 6 where we will implement the on submit function. Now we will save this file again, and then this particular function check the initialized contract. So whether the contract has been initialized or not, then calls the update expense and add new expense functions while clicking on the button. Now let's write the logic to fetch all the expenses which has been added by a user. So there is a wallet address associated with the user, and then we will call the list expenses function on the smart contract to get all the expenses for a particular user, and then we will show the data on the page, and we will copy this and paste this inside our step 7, that is to fetch all expenses to get the expenses data. We'll save this information. In the next step, we are going to run this application. We have completed the logic of the front end functions. Now we will run this application to check whether the application has been built and developed successfully or not. So we'll copy the next command. It is npm run dev, and we will paste it inside terminal and we'll run this particular command. So again, if you see e-access permission denied error, you can again use sudo command. So it is to create some folders maybe. So we will do that. And now I can see that the application is running successfully on localhost 5173 port. So let me just open that. Now, if I can see my front end is running, I can see the total expenditure. But before seeing the expenditure of a particular user, I need to connect that user with the wallet. So I will click on the connect wallet button. It will ask me to enter the password of my portkey wallet, which we have set up already. If you haven't set up, then you can follow the instructions here to set up the portkey wallet. Here are the instructions. You can install the portkey wallet using the Chrome extension. Here is the link for that. And portkey runs better on Chrome, so it is preferred to use Chrome. And then you can set up the portkey wallet by logging in and setting up all the information. I have already set up my portkey wallet, so now I will connect the wallet, and here I will have to provide the password of my wallet, and I will unlock this. So if I go to my expense tracker dApp, it will show me that the wallet has been successfully connected. Now I can add the expense once the wallet is connected successfully. So now I will tell the description that it is, for example, grocery expense. Now let's say enter the amount is, let's say for example 100, and it is related to food. So I will click on food and add the new expense. As the contract hasn't been initialized, so first it will initialize the contract. So we need to sign this transaction. So now it is calling the initializing the smart contract function first. So it will initialize the contract. We'll see a notification that the contract has been successfully initialized. Now we will call the next method to add the expense. Now we will again sign the transaction. So this transaction will add the expense inside the smart contract. So once we add that, we can see that this particular expense has already been added. It has updated my total expenditure, today's expenditure, and last month expenditure as well. Now I can edit this expense, I can remove this expense as well, and I can see when this expense was updated and when this was created. So now I can see the amount and the description as well. So I can edit that. Here the category of the expense is listed. Let's edit this expense and change the amount to 110. And let's update this expense. It will again sign the transaction to update the expense, and it is now updating the expense to the 110 value. So here you can see the value has been updated to 110. And now if I want to remove this expense, then I can click on remove, which will delete the expense. So I can click on this and sign the transaction, which will delete the expense from this list. And once I delete this, then I can see that all the fields above are updated as well. So this completes the functionality which are provided in our expense tracker app. You can try all the functionalities. So here is the description given for all the functionalities. You can check how you can utilize these functionalities. And now you have successfully completed the front end implementation. You have tested the functionality of the expense tracker dApp. Congratulations, you have completed this particular tutorial. I want to conclude this tutorial by saying that we have created an expense tracker dApp where we set up the development environment in the first step. Then we developed our smart contract. Then we deployed our smart contract on the aelf blockchain, and then interacted with our deployed smart contract with a dApp which we just implemented using React. Now, if you want to enhance the security, if you want to add more features to this expense tracker dApp, or if you want to explore the cross-chain capabilities of aelf blockchain, please go ahead and try out these functionalities. You can keep learning, you can keep following us for more such tutorials. We will keep coming up with more such tutorials where you can learn more about aelf blockchain and how to do application development on aelf blockchain. Thank you, and stay tuned for upcoming tutorials.